Okay guys, in this video we're going to be talking about solving systems of equations using the method of elimination. In my opinion, this is my favorite method, but typically you use one or the other, substitution or elimination, depending on the problem, case-by-case basis. So substitution is usually used when one of the variables is already solved for, so one of the variables is by itself. Elimination is used when both of the equations are in standard form and the variables are lined up, so they're kind of ready to cancel. So it depends on what your preference is, however method you want to solve. So what is the purpose here? So the point of elimination is to eliminate a variable so you can only have one left to deal with. So if we only have one variable, then we can solve for it, right? One variable, one equation. What are the steps? So the steps are on this side. So look at the coefficients in front of the variable to make sure that two are opposite. So if there are two that are opposite, great. If not, you can make those opposite by manipulating one of the equations. So make sure that two variables are opposite in terms of coefficients. If they're not opposite, multiply the entire equation by a factor so that they are, and then add both equations in order to eliminate a variable, so whichever variable you're trying to cancel, and then finally solve for the leftover variable. So whatever one you have left, you would solve for it. Now, since you already have one solved for at this point, so you're going to have to go back, plug it in to solve for the other variable by substituting that value into the original equation. So again, at the very end, check your answer. So one of the steps says check your answers to make sure that they make sense, right? So check your answer, make sure that they make sense. If you plug it back in and you get some nonsense, that means you did something wrong. So you should go back and check it. So I have two examples right here ready to show you. How do we solve systems of equations using the method of elimination? So if you notice, let's write some coefficients here. So I have 5x minus 2y is equal to 4. Here I have x, or 1x, right? That's a coefficient of 1. Plus 2y is equal to 8. Now, if you notice, something stands out to me right away. In front of the y, I have the coefficients of negative 2 and positive 2. Now, that means that they're equal and they're opposite to each other, which is great because method of elimination tells me that if I have two coefficients in front with the same variable and they're opposites of each other, I could always add the two equations together in order to eliminate that variable. So if I add the two equations together, that's 5x plus 1x, which gives me 6x. This goes away, and I'm left with equals 4 plus 8, which is equal to 12. So now I have an equation, 6x equals 12, which we can all solve. And if you're in this class by this point, you should be able to solve this with your eyes closed. So x is equal to 2. Done. Are we done? Sort of. So x is equal to 2, but we still have to solve for y, right? So just pick whichever equation looks easier to you. You could do the top one, you could do the bottom one. Doesn't really matter. I'm going to go ahead and pick the top one, just for the heck of it. So 5x minus 2y is equal to 4. I'm going to plug in x because now I know what it is, right? So x was equal to 2, so that goes in there. So 5 multiplied by 2 minus 2y is equal to 4. Now if I plug in x equals 2 and I simplify, I should be able to solve for y. So that will give me 10 minus 2y is equal to 4. Subtract 10 on both sides, minus 10 minus 10. I get negative 2y is equal to 4 minus 10, which is negative 6. Divide by negative 2, divide by negative 2. Boom, y is equal to positive 3. Done. So my final answer for this system of equations is equal to x equals 2 and y equals 3. Again, I'm done. I am done, but check your answer because you never know. For all you know, you made a mistake and then something went wrong and then you got a weird answer because it doesn't actually add up. So if you go back and check, I'm going to do a little check real quick on the back of another random paper. So x equals 2, y equals 3, right? So if I go back and check these equations, so x equals 2. So let's see if it works out. 5 parentheses 2 minus 2, y equals 3. So I plug in 3 is equal to 4. Does that make sense? Let's see. So 10 minus 6 is equal to 4. Oh yeah, that works. 4 equals 4. So that means that my answer is correct. So let's check the other one now. So now we're going to check the 1x plus 2y is equal to 8. So let's check that. X was equal to 2. So that's going to be 2 plus 2 times y, which happens to be 3. And then set that equal to 8. So that's 2 plus 3 times 2 is 6 is equal to 8. So we get 8 equals 8. Again, that makes sense. So we are correct. Our answers are 100% right. So Even though you got the answer, go back and check just to make sure you got it correct. Example 2. Here we go. So we have to solve the system of equation for by canceling out one of the variables by elimination, right? So something stands out at me again. In front of the y's, I have a -2 and I have a -2. That's pretty good, but we want those to be equal and we want them to be opposite. So one of these has to be a +2. Pick one, doesn't matter. I'm gonna go ahead and pick the bottom one. I'm gonna say, okay, I want the bottom one to be the equal and opposite of that. So instead of -2, I want the bottom one to be a +2. So I'm going to multiply that whole entire equation, because I can't just do the y, right? It's a whole equation. So I want to multiply that whole entire equation by -1. If I do that, that will assure me that that would be a +2, right? If I multiply that by -1, that'll be a +2, and then they will cancel. But I can't just do it to the y, I got to do it to the whole entire equation. That means I got to do it to the x, I got to do it to the y, I got to do it to the -5. So now it's going to give me another system. 6x minus 2y is equal to 10. That I just rewrote. And then I'm going to rewrite this one more time. This is going to be -1x. That's going to give me a +2y. And that's going to give me a -1 times -5, which is 5. Now that I multiplied everything by the -1, I can cancel my y's, same as the last one, right? So if I add up the two equations, I get 6x minus 1x, which is 5x. The y's go away because -2 and +2 cancel. And then I get 10 plus 5, which is 15. So I get a simple equation, 5x equals 15. Now I can solve it, right? Divide by 5, divide by 5. I get x is equal to 3. Bam. So I have one equation, or sorry, one variable done. Now I have to solve for the other one. Pick an equation, doesn't matter which one. I'm going to go ahead and pick the bottom one. Now the bottom one says x minus 2y is equal to -5. Now since I know what my value of x was equal to 3, I can plug that into the x value. So now I'm going to replace this with 3 minus 2y is equal to -5. Again, I can solve this now because I have one variable, one equation. So I draw the wall or the line, subtract 3 on both sides. I get -2y is equal to -8. Divide by -2 on both sides, divide by -2. Y is equal to 2 times 4 is 8, so therefore is equal to +4. So I got my answers now. So x is equal to 3, y is equal to 4. So I'm done. However, again, I emphasize, if you can, if you have the time, just go back and check your work. You lose like 30 seconds and then you know that you're 100% right. So let's check your work. So x equals 3, y equals 4. So let's go back and check these two equations to make sure they work. X equals 3, right? So 6, let's do the first one. 6, 3 minus 2 times y was equal to 4. And then that was equal to 10. So plug it back in, let's see if it makes sense. So 6 times 3 is 18. 4 times 2 is 8. And then that's equal to 10. So we get 10 equals 10. That checks out. Cool. Let's check the other one now. Let's see if that one makes sense. So x was equal to 2. Y was equal to... Wait. Timeout. Uh-oh. 3 and 4. I'm sorry. Did I mess up this? I think I may have messed up this. Yeah, I totally wrote down the wrong numbers, huh? I am... Wait, what the... Oh, no. I did it right. Sorry, I was flipping the paper on the wrong side for the other example, and I totally, confused myself. Okay, never mind. We're good. So, if I go back, check the other equation. X is equal to 3. And then y is equal to 4. So -2 times 4, and then that's equal to -5. We get 3 minus 8 is equal to -5. Again, this becomes a -5 equals -5, which again makes sense. So we got it right. So don't take your own word for it. You can go back and check it anytime to make sure that you get the equations correct. Okay, now let's do one last one. This is like the hardest that it's ever going to be, so I want to do one of these examples for sure. The example is, okay, what about when nothing looks like it goes together? You could still solve it using elimination. You just have to be a little more creative. So let's say, for example, I have a 3 and a 2 in front of the x, and I want to eliminate the x. Now, I want those two to be opposite. So that -3, I want that to be opposite to that -2. I have to be a little more creative, meaning that I have to multiply both equations by something so that they cancel out. So I can multiply the top one by a 2, right, to make that into a -6. And I can multiply the bottom by a -3 to multiply, and then that would turn into a positive 6, and then therefore they would be opposite, right? So this would turn into a negative 6, that would turn into a positive 6, and therefore they would cancel. However, since I have to do it for the first part, I can't just do one multiplication and that's it. I have to multiply the whole entire equation. So if I multiply one, I have to multiply them all. So I'm multiplying all three terms for the both top and bottom. So this is the hardest it's ever going to get, when you have to multiply twice. Now, if you do it this way, you should be getting negative 6x. 7 times 2 is 14, so positive 14y. 2 times negative 1 is negative 2. Drop this down. This will give you positive 6x, which we wanted, right? We expected that. 5 times 3 is 15, so negative 15y. And then set that equal to negative 3 times 0, which is 0. Now, the cool thing about it is that we accomplished our mission of making those two equal and opposite. So that top should be a negative 6, even though it looks ugly, and that bottom is a positive 6. So this will cancel out, and we're left with negative 1y is equal to negative 2 plus 0, which is negative 2. So easy to solve now, right? So we divide both sides by negative 1, divide both sides by negative 1, we get y is equal to positive 2. Done. The first one is the hardest one to solve. Now, if you want to solve for another variable, again, you got to plug it into one of these equations. What looks easier? Whichever one looks easier, choose that one. I think the bottom one looks easier, so I'm going to go ahead and plug it into the bottom one. So, oops, dropped my pen. So we're going to plug it into that one, just for the heck of it. Negative 2x plus 5y is equal to 0. I'm going to plug in y, because that's the one we solved for. Y is going to be equal to 2. So negative 2x plus 5 times y, which is 2, is equal to 0. Solve for x. Now it should be easy, right? So negative 2x plus 10 equals 0. Draw the wall, subtract 10 on both sides, minus 10 minus 10. You get negative 2x is equal to negative 10. Divide by negative 2, divide by negative 2. We get x is equal to positive 5. Done. So then the final answer for x is equal to positive 5. Again, you're done, right? But just for the heck of it, you should check your answer just to be safe. So the answer is 2 and 5, right? So I'm going to do it here on the side. So just a little check. X equals 2, y equals 5. So now if I plug it into the equation, it's negative 3 times 2 plus 7 times 5, which is y, is equal to negative 1. Let's check that. So that is negative 6 plus... Wait, did I plug that in right? Oh, might be. Okay, so x is equal to 5, right? So this one should be a 5. And then y was equal to 2, so then this one should be a 2. What am I doing? Well, this is what happens when you're recording videos in the middle of the night in your kitchen. Okay, so then that's going to change. So 5 times 3 is 15. And then this is going to be 14. And then that's going to turn out to be negative 1. So that works out. If you check the bottom one, negative 2x plus 5y equals 0. Let's see. So negative 2 times x. So negative 2 multiplied by x, which was 2. I'm sorry, 5. See, this is what messed me up. So x is 5, y was 2. So negative 2 times 5 plus 5 times y, which is 2, is equal to 0. That's a negative 10, positive 10. And yep, that does cancel out, which adds up to 0. So we did it correctly. So even though you know you're done and you did it, just make sure you check your work, because you never know, you may get it wrong. All right, see you guys on the next one.